Okay, then we can then use some tools to actually analyse this assembly. So at the minute when we rotate, it's obvious to us that we have some collision there, but we can get the software to look at that. It's easy in a simple model like this to spot these visually, particularly as it's quite a lot of collision. But if it was only very slightly touching or it's a more complicated model, we may miss things like that. So we can do a tools interference detection, click calculate. That will show up any collisions within just this position of the model, and if I select them, it highlights in red any bits where the parts are touching, so we can get rid of that. Okay, so we know we've got some collision going on around here around the pin, so if I just open the pin up on its own and then do a tools measure there, the diameter of that is 23 millimeters. Go back to the assembly and open the piston head up on its own and then do a tools measure. You can see the diameter of the hole is 22 millimeters, so quite rightly it's found a collision between those two parts. Effectively the pin is too big for the hole. Now just to go back and correct that problem quickly, we'll go back to the piston pin and we'll go back into the original sketch and we'll change that to be 22 millimeters. Okay, and then back to the assembly. It's noticed that we've changed some geometry, so it's asking want to update. Always click yes there. And if we then do a tools interference detection again and click calculate, we'll notice now there's no interferences, there's no material overlapping. But what we might want to do is treat coincidence as interference. Now what that will do, any parts that are touching but not overlapping will show up as interference. Click calculate there, and what this is checking is that the pins are the same size as the hole, so the nominal size of the pin is the nominal size of the hole. And we just look down the results there. It's quite a useful feature just to check if you've got any gaps in the model.